Hello everyone, good day. My name is Frederico Zaniol and I will present you the Rio de Janeiro case study via IMM methodology. First of all, what is the IMM? IMM designLab is an international multidisciplinary design laboratory for urban sustainability. IMM is also an acronym of Integrated Modification Methodology, a design methodology with the main goal of improving the complex adaptive system energy performance by using an holistic, multi-layer and multi-scale approach. In the IMM methodology, we investigate the relationship between the urban morphology and energy consumption. For us, the city is considered as a dynamic, complex adaptive system composed by different layers or sublayers. It is the arrangement of these sublayers that provides the entire system performance. During the entire process, our main goal is to achieve a more sustainable and better performing urban environment. So based on this theory, the city is not just an aggregation of disconnected elements. In our analysis, the city, or the complex adaptive system, can be dismantled in four main horizontal layers: volume, voids, transportation, and functions. These layers are vertically connected, composed by the 6 key categories, or similar to the vertical layers, divided in porosity, proximity, diversity, interface, accessibility, and effectiveness. So, why the Rio de Janeiro? Well, first, Rio is a megacity, with the population up to 12 million people living inside its metropolitan area. Second, the city is under transformation, probably due to the presence of the major world events nowadays. And last but not least, the city is in a constant expansion, which can be visible when you take a look in the Rio's favelas, enlarging the city almost every day. The second question could be, why the Porto Maravilha zone? Well, first, is a central urban area also in transformation with the implementation of the project Porto Maravilha. This project has a goal to transform the area, increasing the local population by more than 300%, jumping from 32,000 to 100,000 inhabitants. This huge project, of course, is creating several controversies with the local community and the public authorities. The local community claims for a better integration between them and the project area. But also the location is an attraction as well. The Porto Maravilha area, it works actually as a city hub, gathering everyone who arrives in the city, either by airplane, by train, by buses, by private cars, or by boats. The Porto Maravilha area is also directly connected with the main business area, the downtown, with the main touristic area, the South Zone, where is Copacabana, Ipanema, Leblon, and Pão de Açúcar, and with the most populated residential area, the West Zone. In this presentation, we will focus on the 3 steps that compose the IMM design process, which are formulation, modification and intervention, and the transformation. The first step consists in defining a local and intermediate scale by using the urban morphology. After, the selected area is disassembled according to the IMM methodology, which is, we split the area into the horizontal layers, volume, voids, transportation, and function for a better investigation. Then, to understand the actual system performance, it is investigated also the 6 key categories: porosity, proximity, diversity, interface, accessibility, and effectiveness. From our horizontal analysis, we detected 4 main things. First, a good transportation system, taking in consideration the one planned by the Porto Maravilha project. The second, a compatible presence of function in the area. Third, the volume is fixed as a constraint to host the new population demand. And by the end, a disconnection between the biggest voids in the area. So our work was mainly working in the void layer, and also with the three key categories that connected to it: porosity, diversity, and interface. The porosity, or volume and voids, which means how the volume is accommodated in the area, did not show any promising transformation due to the fact that the volume request is fixed and necessary. Diversity, voids, and functions, which means how the different functions are located in the area according to the uses, was not the most appropriate key category to be worked because the actual performance looks more to be a consequence than a cause for the entire system arrangement. Leaving in this way the interface, or the voids, and the transportation, defining the quality of the movement within the void network to be the work as a catalyst layer. To investigate the interface, we use the space syntax theory, developed by the University College London and suitable to investigate the configuration of the voids network, which in the Porto Maravilha case was very low and possible to be transformed. Formulation. So the formulation phase is basically choosing the catalyst layer to work on. In our case, the choice was to work on the interface to modify the void layer. It was also part of the formulation phase, the rearrangement of the IMM design ordering principles, or the DOPs. In this case, was defined as priority the sequence of action as creating connected open space and protect the urban biodiversity, foster mixed-use spaces, promote walkability, promote cycling and reinforce public transportation, foster local energy production using the building as a component, change from multimodality to intermodality concept, promote ground use balance, prevent the negative impact of waste, implement water management, and convert the city in a food producer. Modification and the intervention. The new DOP's arrangement guides the modification and the intervention phase. In a global scale, the modification intent to create a metropolitan green network, linking the local area to the Tijuca forest by connecting the available green space. At the intermediate and local scale, we define the proper connection of the urban empty spaces. The space should be recovered when necessary, in order to create a local green network to be further connected to the metropolitan scale by the two adjacent parks, the Quinta da Boa Vista and the Parque Aterro do Flamengo, respectively at the left and the right sides on this map. Following the second and the third DOP, foster mixed uses and promoting walkability, the decision was to enhance all the potential spots within the actual interface, creating the more integrated circulation flow inside the area. Then, following the fourth DOP, the modification will be regarding the existing connections. The red lines shows the connection that will be enhanced by new pedestrian and cycling lines. Then the yellow lines that are showing the connections that due to the existing topography could not be improved by using cycling, only by pedestrian uses. Then the transformation. As presented before, the transformation will follow these steps. First, detecting all the empty urban space, to then characterize them according to the type of surface. Second, treating them properly, using natural surface in order to enhance the urban biodiversity and to mitigate heat island effect. Third, to create two axial green corridors, or the green boulevards, to work as linear parks. After, connecting them with the green fingers, connecting the waterfront line from the city green network. As first step, the actual morphology near the waterfront will be adapted to the interface needs and also to fit with the city's existing morphology. By the end, accessibility at the hills and over the railways should be also improved. Volume optimization. Done with the transformation, we needed to optimize the volume in order to accommodate it inside the new interface. For this, we calculate the maximum area requested by the Porto Maravilha project, achieving a 7 floors tall monolith. After, the monolith will be cut longitudinally towards the coastline and transversally. Further, the total volume is redefined according to the plot's hierarchy values as a consequence of the proximity to the transportation nodes. It allows us to locate the major amount of volume near the most important intermodal transportation hub, giving the possibility also to decrease the volume where the supply of transportation facility isn't high enough. It also provides the chance to manipulate a little bit the volume at the blocks located near the waterfront, providing more natural ventilation and better insulation in the area. At the end, we have the same volume as requested by the Porto Maravilha project, but now adapted to the new interface as well to the transportation system. Comparison. As a matter of comparison, recalculating the system, we detect an enhancement in the void layer of 4.4 more area available with the same build volume. Regarding the interface, it was possible to enhance its integration in 21%, which affect also the integration and the performance of the adjacent areas, as the downtown, for example. Concluding, the demonstration of the case study helps us to understand the role that urban morphology plays when analyzing cities' performance. The IMM methodology is a tool for detecting the actual urban performance. As well, it can act as a guideline, transforming it in order to achieve better results. Thank you so much for your attention. I hope you like it. And to see more about our work, please visit immdesignlab.com or follow us on the Facebook.